Geometry lesson 2.8. We are talking about bisectors and continuing on with midpoint. Let's recall that the definition of a midpoint. If M is the midpoint of AB, then M is the midpoint of AB. Remember this notation. And the segment AM will be congruent to MB. So M is the midpoint. It's exactly in the middle of A and B. So if this total line was a coordinate of, or this total line was a distance of 6, then AM would be 3 and MB would also be 3. The distance between the endpoints of a segment is the segment's length or measure. So if I am asking you to find distance, they're talking about its length or measure. You should have a piece of paper for this lesson and write all of your formulas on it. Put the name of the formula and what it's for next to it. This will keep you out of trouble on the homework. Here's our first formula in this lesson. We've already learned this formula. This is the formula to find distance between two coordinates on a number line. And segment AB, this is the same segment right here. We have coordinates, and these coordinates are named with small letters. They will respectively line up with the large letters on your number line. So in these formulas, when you see the small letters, remember that if there are large letters on the number line, this is what they're talking about. So segment AB equals the absolute value of A minus B. Remember also that if you're doing an absolute value problem, many times there will be two answers. So let's look at example 1. Example 1, find the coordinate. Be careful to read these problems correctly. Sometimes they're asking for distance, sometimes they're asking for the coordinate of T, and I put in brackets a small t here. And look at the number line. I've rewritten the information from your book that's on the number line, but I also added these small letters as the coordinates. So find the coordinate of T. If the coordinate of M, the midpoint of RT, there's R right there, there's T, is 2. So we know that M is 2, and the coordinate of R is 5. So now you've taken your given here, and you've filled it in on your number line, and you know exactly where all of your properties are. The answer. First thing you need to do is remember that MR equals MT. This is a midpoint, so the distances will be equal. So from just looking at the number line, we can tell that the distance from M to T is 3. You go one space at a time. So 1, 2, and 3. From M to R, the distance is also 3. 1, 2, 3. So you can do that visually. Now, we're going to use our distance formula. The distance formula was back here. This AB equals the absolute value of A minus B. We're using that distance formula, and we're going to substitute our numerical values for our coordinates in there. So MR, M is 2, R is 5. Now you may be asking yourself, why are we not putting the 2 here and the 5? Actually, you can. You can say 2 minus 5, which would be a negative 3. But we're doing absolute value, so the answer will still be 3. If you're smart, you'll start with the larger number to subtract, and then you'll end up with a positive answer. Now this problem is just a little different in that to solve the second coordinate, because this is absolute value, there will be 2 answers. They substitute this little t here. Remember, the small t is in the same spot as the large T. It's also the coordinate, the numerical coordinate, -1. So mt equals t minus 2, the absolute value of t minus 2. And when they solve that, well, one of the things we know is you stated here that mr is 3. The -1 minus 2 is also 3. So t minus 2 equals -3, or t minus 2 equals 3. Now where did I get the -3 from? Well, that was the actual math we did. When you take -1 minus -2, it's the same as saying -1 plus -2, which is -3. So you'll have on your opposite sides of your midpoint 3 numbers to the negative, 3 numbers to the positive for your answer. So we have mt and we have mr. We can go ahead and continue to solve here, and t, if we have, we've solved that t equals -1, or t equals 5, right here, by continuing to use algebra to solve. And our answer is actually t equals -1. Even though you had 2 answers here, we already know that the coordinate r was 5. And they asked you, what is the coordinate of the small letter t, or the coordinate of t? So I know that's a little confusing. When you do it with your problems, you won't have to do it exactly this way, so it won't be as confusing. But the important thing to know is that you use the coordinate to find the coordinate on a number line. You're going to use the formula for distance. We also have a formula for the midpoint theorem. This helps us to solve the midpoint of a segment. So if m is the midpoint of AB, then AM equals half of AB. We know this to be true. We've already shown this. If AB was 6, we know that AM is 3 and MB is 3. So 6, if we were to fill this in, AM would equal 1/2 of 6, which is 3. So this is the midpoint theorem, and on your homework I tell you which theorems to use for which problems. We also have a formula for the coordinate of the midpoint, and remember the coordinate is finding the small letters. So now you can say that m equals a plus b, so whatever this coordinate was, plus that coordinate divided by 2. Depending on the information you're given, you can often interchange these formulas. So example 2, let's find the coordinate of the midpoint m of segment PQ. P will equal -15 and Q will equal 7. Then it asks you to use the midpoint theorem to verify the result. In your homework problems, they usually only want you to do the first part of what we show in this example. So you begin by drawing a picture. So here's our picture of our original formula. And we're going to apply that midpoint formula to what we were asked to do. So go back and look. It says the line segment was PQ. So let's just change this. And we'll call this P and Q. And that'll give us small letter coordinates P and Q. And this will be M. Now you can substitute those values in your formula. So you can see the original formula right here. I substituted the information we were just given. Same formula, just different variables. And now we'll use our numerical values. P equals negative 15 plus Q is 7 divided by 2. Negative 15 plus 7 is negative 8. And that's divided by 2. And our answer is 4. Our answer is negative 4. Now they asked us to apply the midpoint theorem. So this is the formula for the midpoint theorem. And I'm changing this formula to match what we have here on our number line. So instead of AM, we have PM. And note, this is half of the segment. So PM equals half of the total segment PQ. We can substitute our number values here. And, well, it won't let me erase it without doing some major things. So I'm going to cross it out. I was just using this to show you what the original formula looked like. This is actually PM. So PM equals 1/2 PQ. So the distance, PM, is absolute value of A minus B, which is 11. And the midpoint theorem, 1/2 PQ, would be negative 15 minus 7, which we saw up here, divided by 2 or multiplied by 1/2, which is also 11. So that's how we just proved that this is correct. If the coordinate we found here, which was negative 4, was not correct, then this would not be the correct notation. You would not have 11 equals 11. Okay, a couple of definitions. Segment bisector. A segment bisector intersects a segment only at its midpoint. So if you have a segment, if you have a really nice straight segment, a little better. The bisector intersects it only at its midpoint. The line, ray, and segment, or plane, there's my line that I was looking for, that forms right angles when intersecting the segment at its midpoint is called the perpendicular bisector. So you can bisect a segment with other things besides lines. You can also bisect a segment with a ray, with another segment, or with a plane. And if it forms a right angle, we now have what we call a perpendicular bisector. You can actually have a segment that's bisected, say by another line. It goes through the midpoint, but it doesn't form a 90-degree angle. So if it does form a 90-degree angle, it's a perpendicular bisector. And this picture here is for the congruent segment bisector theorem, theorem 2.8.2. If two congruent segments are bisected, then the four resulting segments are congruent. So we're basically saying that segment XY is congruent to segment KL. And I'll say that XY is 6 overall. And so that means consequently KL would also be 6. If these segments are bisected, that would mean that XA is 3 and AY is 3 and KB is 3 and BL is 3. So these resulting segments are all congruent to each other also. Another definition, the ray YT is the angle bisector of the larger angle XYZ. If that ray YT is in the interior or inside of the angle XYZ. And the measure of these two angles, XYT, which on your drawing is angle 1, equals the measure of TYZ, angle 2. They're also congruent to each other. This leads us to the angle bisector theorem. And if ray YT bisects angle XYZ, then the measure of angle XYZ, XYT, which is angle 1, equals 1/2 of the larger angle. The congruent angle bisector theorem, if two congruent angles are bisected, then the four resulting angles are congruent. So if we had another identical angle, and it was also bisected, then the two angles that you would have in that drawing would be congruent to the two original angles. So angle 1 would be congruent to angle 2, and angle 1 would also be congruent to angle 3 and to angle 4. And angle 2 would be congruent to angle 3 and angle 4 also, and vice versa. So these are some hints about doing your homework. For number 1, just use the number line to find your answer. You don't need a formula. Number 3 and 4, use the formula for the coordinate of a midpoint. This is why I said write the formulas down on a piece of paper and then write what they're for. Then you can go straight to the formula. Number 16, use the formula for the midpoint theorem. Number 27, solve using the formula for coordinate of a midpoint. Number 30, solve using the formula for distance. Number 36, make a 2-column proof with 4 steps. And here's your word bank. Now, number 33 is a problem that's a real reach. It's a little bit outside of your knowledge at present. So on the next slide, I'm going to show you how it's solved. And if you want to look at that when you're, if you want to rewrite those steps while you're doing your homework, that's fine. And I'll go over it in class when we get together again. So for number 33, it says, given line segment AB with midpoint M. So this is the drawing you're familiar with. where m equals a plus b divided by 2, familiar formula, show that mb equals 1/2 ab. So this is a proof. This is a mathematical proof to show that mb, this distance, equals half of the total distance. Okay? So mb is congruent to the coordinate b minus this formula right here. So b, absolute value of b minus the formula for the coordinate of the midpoint. Now these are two, essentially, if you look at this, these are two fractions. But we cannot subtract these fractions from each other because they have different denominators. So we have to set both of the denominators the same. Well, 1 times 2 is 2, so let's multiply b by 1, and remember 1 can equal 2 over 2. So doing so, we end up with 2b over 2 minus a plus b over 2. If we combine those, we end up with 2b minus b, which is b, and we have a left on the right side of the subtraction mark. So it's b minus a divided by 2, which is the same as saying b minus a times 1/2. But we're working with distance here, so we're working still inside of absolute value bars. And if we combine this formula, we know that these coordinates, the small coordinate letters, a and b, are the same as the large points, a and b, on your number line. And we can now restate this as 1/2 ab. So you just proved that this was 1/2 ab. Go ahead and do your homework. Be sure to check the email out that says the change for your lesson plan for today and for tomorrow, or for Monday. Call me if you need help.